Hi folks, I want to do a quick intro video for the manipulating equations. This is what we're going to be working with to move into systems of equations, but I just wanted to kind of do a general intro of what we're saying here. So sometimes I think of this like a scale, the old style scales where it just balanced out on either side, and you've got this axis here, this fulcrum, if you want to call it that. And then basically I've got stuff on either side of the scale, and as long as those things, in the case of the scale, as long as they have equal gravitational pull or weight here on Earth, as long as this side is pulling down the same way that that side is, then they'll always stay lined up. So these will be, more or less in line. And what we say in that case, we say, well, this side is equal to that side. Let me do that in a different color. This side is equal to that side. They're the same. They're doing the same thing, so the scale is not imbalanced. So they are the same. Now, in algebra, we can use this idea to manipulate equations to say, well, if I know a statement, if I know something is true, then I can play with it, and as long as I play with it in a way that keeps everything equal, not necessarily the same, but equal, then I haven't changed anything. I can say something else is true, and I can use that idea of algebra to find something that's unknown. So in this example of the scale, let's do another one here. I've got this side here, and it's more or less balanced with that side there, as long as what's the same on both sides. So what I can say is, well, if I add something on this side, I don't know what it is, but let's say I add it, okay? As long as I add it on this side, it will still be balanced. I can still say that these are equal. Okay, so I can add the same thing to both sides, or I can subtract the same thing from both sides, right? I could also take off the block, and well, then it would just look like this, right? It would be empty, no block, no block. So I could take it, I could go from block to no block, or I could add the block on. And I think that's pretty intuitive. I could also multiply, right? I could also multiply. I could say, well, I'm going to multiply both sides by 2. So let's say I'm going to multiply this side by 2 times 2 times 2, okay, and as long as I do it on both sides, well, what would that look like? Well, then I'd have 2 red blocks. So now instead of 1 red block, there would be 2 red blocks on each side. 2 red blocks on each side, and those would, if they were exactly the same, be balanced. And the statement would still hold. This is still true. These are still equal. The same thing also works for division. Say I started with 2 blocks on each side, okay, 1, 2, 1, 2. I could divide each side, divide this entire side in half. Not each block in half, but each side in half. Whatever I do to one side, I do to the other side. Okay, and if I did that, basically I'd be removing a block. So what would that look like? Well, basically, if I have 2 blocks on this side and I cut 2 in half, well, then I'm left with 1 block. So I'm taking 1 block off each side, or really I'm taking the whole side, 2 blocks, and dividing them by 2. 2 divided by 2 is 1. So now there's only 1 block on both sides. But it's important here that when you're multiplying or dividing, you're doing it to the entire side. Everything on that side has to be cut in half, and we'll do an example of that. But when you're adding or subtracting, you're only doing it to the side once. And we're going to look at the reason for that in the next video.